Lord. You're still on camera, Keith. All right, so I want to welcome everybody to the Silicon Valley Javafx user group. So we usually have about monthly meetings, second or third week of the month, and we also live stream all of our meetings. If you go to my blog, stevonjava.com/svgfx, and we're also, this is the first time we're dual streaming, so this is showing up with the Night Hacking website as well. So if you go to nighthacking.com, you can also check it out. And we'll be monitoring the chat during the session. So if you're online, feel free to type into the chat window on the Silicon Valley Javafx user group, and then we'll be happy to take questions or comments from the audience online. And then note about our sponsors. So thanks to Oracle for providing the venue and the food and the wonderful brownies. I think we got compliments on the brownies. And also for JFrog, because they pay for some of our meetup fees. And who else am I missing? IntelliJ gives us free licenses to give out at the user group. And Linode does some of the hosting for us.
Parlays.
Oh, and Parlays where we used to post videos, but I got lazy.
Yeah.
Oops. All right, Stefan, I'll post this one on Parlays. Apologies. All right, so with that, I'll let Ryan take over and talk a little bit about JavaFX and HTML5. So welcome.
Okay, thank you. Thanks, Steve. I'm Ryan Cuprak. I work for Dassault Systems. Just out of curiosity, how many of you have heard of Dassault? Okay, that's good. We make software CATIA, SolidWorks. So if you flew out here on a plane or drove a car, it was probably designed using our software. I actually work for a group that does chemical formulation software. So you've probably used something today that was designed with it, whether it was a soap, a shampoo, over-the-counter drug, etc. So we actually use, it's actually written using Java, and it's a desktop Java application, so hence my interest in JavaFX and desktop Java. So this presentation I actually gave at Java 1, and the genesis for this presentation was, and many times I've heard the question, why JavaFX? There's HTML5, why is Oracle investing in JavaFX? What's the purpose of JavaFX going forward and desktop Java? So with that, I'll dive into the presentation. The presentation tonight, the first part of the presentation, I'm going to put JavaFX and HTML5 in perspective, going over the major features, the history of each, and then finally doing a technical comparison of both of them, then going into how to integrate both of them together to actually make them work together after basically ripping both of them apart, and then finally summarize. So, JavaFX in perspective. So looking back at the history of JavaFX and HTML5, HTML5 actually started, initial development on it started around 2004. Actually at the time, XHTML was actually thought to be the successor. It was already in development at that time. So HTML5 was actually something that organically grew out. It was not, a decision by a main body back in 2004 to actually decide to begin building or designing HTML5. The origins of HTML5, for instance, the Canvas in HTML5 came out as a result of Apple and their widget desktop thing that they wanted. They wanted to be able to put up that, I forget the widget thing where you press the keyboard and you have the different JavaScript widgets. So that's actually what resulted in the initial development of the Canvas. WebGL, which is not technically a part of HTML5, came about as a result of somebody saying, well, the Canvas is cool, but what if we made it do 3D? So that's how WebGL came into existence. So the origins of HTML5 are from many different places. There's not one main designing body that was driving the design of it. So 2004, specification development began. Around 2006, W3C switched to HTML5 from XHTML. And so there were a couple of years there were some confusion as for XHTML versus HTML5 and which way things were going to go. 2008, the first HTML5 draft was published. And then really it's been within the past 2 years that you've gotten browsers that are actually capable and support large enough features of HTML5 that you can begin to use it. JavaFX actually has, as we know, has a slightly different history. It was first announced at Java 1 in 2007. Initially was at the time pitched as being like a mobile phone technology. It was a separate download from Sun at the time, and also a separate language. So in order to work with JavaFX, you had to download it separately, and it required learning a separate language. So it was finally with the purchase of Sun by Oracle that Java got folded into the main platform. And I like to think of JavaFX 2.0 as kind of being the 1.0 release, with it being rethought out and integrated into the platform. So they've been both kind of developing in parallel, with JavaFX having a newer history. Some common JavaFX misconceptions. Now, this audience, I believe most of you are JavaFX developers. How many of you are HTML5? Okay, this is usually when I'm giving this presentation, there's one JavaFX person and the rest are HTML5. So some of the common JavaFX misconceptions is that JavaFX is irrelevant with the advent of HTML5. Java on the desktop is dead. That's definitely not the case. In fact, to see a good listing of desktop Java applications, if you go up to the NetBeans website, there is the NetBeans platform example applications where they list probably 50 or more vertical applications written on top of the NetBeans platform, which are all rich desktop applications doing many interesting things, such as simulation programs for Boeing, farming applications, all kinds of very interesting things that are done on the desktop. The other misconception is that JavaFX and HTML5 are mutually exclusive, and I'll kind of touch upon that later in the presentation. In fact, JavaFX's support for HTML5 is a reason to actually use JavaFX in an existing Swing application, for instance, because JavaFX does embrace HTML5. Java does not have good graphics performance. That's definitely not true with JavaFX. JavaFX is for rich media applications, not your traditional desktop application, which is using form-based type application where you are entering data and everything. So in the early pitching of JavaFX, there was a lot of the demos with the globes with 10,000 movies on it playing and everything like that, which to a standard business, somebody that's developing more of a spreadsheet application goes, well, that's nice, but that's completely irrelevant to what I'm working on. That's definitely not the case. JavaFX, and kind of tying into that, JavaFX is meant for only building games and mobile apps. You can actually build real business apps using it. And the final misconception is that you never use JavaFX in a business application, where it's actually a pretty good fit for it. JavaFX versus Swing. JavaFX, and this has actually been stated at conferences, is a replacement for AWT Swing. Unlike Swing, JavaFX is not built upon AWT. This is actually a favorite trick question I like to ask people is, AWT is not dead, Swing is actually built on top of it. So many of the limitations that AWT has, Swing also has. So Swing, Swing goes all the way back to, its early history with AWT. Not much has actually changed there. So why replace Swing? What's the purpose for replacing Swing with JavaFX? And if you've worked with Swing long enough, you know that there's a lot of, it kind of looks nice initially, but then the further you dig into it, there's a lot of different issues and problems with it. There's architectural limitations that prevent graphics acceleration. And by graphics acceleration, I don't mean the flags that you can pass into the JVM for turning on hardware acceleration. There's other things with like scene graphs and being able to do real graphics. Incomplete look and feel support. If you've ever tried to extend the look and feel or change the look and feel of an application to say, provide a custom look and feel for your application, it's an extreme amount of work, and there's many dead ends that you'll discover where things, are just, you can't actually get to them or change them. Poor component extensibility. It lacks multi-touch support presently, and given the current state of the Swing API, I don't see how you could ever get multi-touch support in there, and have it fully supported. It wasn't designed for it. And there's a lot of historical baggage that prevents evolution of it that's kind of been incurred over the time. And in terms of, and also just touching on the architecture of it, if you've tried to extend as you're developing custom components, you'll discover in many cases that classes that you need to extend are package protected. There'll be one method that you actually need to do to implement something, and there is no way you can get it unless you copy the Sun code into another package and then pull 50 other classes with it to try to work with it. So there's a lot of, it looked nice. It's much better than what was there before, much better than AWT, but it never quite reached its full potential. So legacy technologies, JavaFX, given that JavaFX supports 3D and media and everything, there is quite a bit of confusion because there was previous attempts at Java 3D, Java Advanced Imaging, and Java Media Framework. All of these are dead and they're not related to JavaFX. So Java 3D is not the same thing as JavaFX 3D. Java Media Framework is not the same thing as the media support that you have in JavaFX. So JavaFX, unlike these technologies, is cross-platform. The features are available everywhere, which was not the case with some of the JMF stuff where it was supported on one platform but not the other platform, and it was always one behind. Or you'd have for some platforms you'd have native libraries that would do acceleration, but then other ones would run in actual Java code. JavaFX, unlike with taking JMF into account, JavaFX includes support for common video and audio formats. Finally. So some of the key JavaFX features, first of all, it has retain mode graphics. It uses a scene graph underneath the hood. The scene builder tool, so finally we have a standard tool for constructing Java desktop applications. You don't have to work with, use CodeGen, use an IDE specific thing like a tool specifically from IntelliJ or from Eclipse. They've also most recently open sourced the scene builder. So you can actually check that code out and begin making changes to it. I've actually done that and had some fun playing around with it. I'm looking at extending it because you can use it to build up, like a custom editor for your application using that. So you can finally do things like that. The other thing that it adds, unlike the GUI designers inside of NetBeans or IntelliJ, it doesn't generate code to display your UI. It actually has an XML format, finally, an XML format that describes the UI. So that's one of the other major advantages or benefits of JavaFX. It's got 60+ components out of the box. If you look at Swing, the core Swing library of components is maybe a dozen or two, and it hasn't changed since it was first introduced. There's really been no additions to the library of components. And then in terms of skinning components with look and feel, you don't have to subclass and create a look and feel and deal with all of that overhead. You can use CSS for skinning. And I'll touch upon this a little bit in the presentation. It also has built-in support for animation. So if you're coming over from like iOS, where you have animation APIs, JavaFX does have support for animation. It's got audio-video support, which I've touched on already. Also has multi-touch support, so you can use the pinching, the zooming, and all the rest of it. And then it does have 3D tooling, 3D support and tooling support with 3D, with the most recent version of the Scene Builder tool. JavaFX in perspective, one of the differentiating features is the scene graph is at the core of the API. So if you were writing a Swing application and you wanted to create, you wanted to be able to zoom in on part of the UI, or you wanted to have an animation where you animated the widgets, that was really hard to do, right? You were limited to, if you wanted to put and dim the screen, you were limited to one glass pane on the screen. Doing anything with fancy graphics, transitions, making a component, expand in size or something like that, you really couldn't do that. So the UI widgets, text fields, labels, buttons, are nodes just like any other node. So there's really no difference. UI widgets are the and as I mentioned, they can be animated, transformed, filtered, leveraged, etc. So you can create some of the nice, fancy, snazzy UIs like you see on the iPhone with special effects. So you can easily write a banking application that as you move through the wizard, the screen slides over, it fades in and out, you throw up an error message, the screen dims. You don't have to write all kinds of complex code. So many of the things that if you read the old, there's a good book on graphics programming for Swing, I forget the name of it. Top of my head. Yeah, Filthy Rich Clients. So many of the things that were covered in that book are much easier to do with JavaFX now. So switching gears to HTML5. So some of the major features of HTML5, and after I go through these, I'll compare this to JavaFX. Major features are the 2D canvas, WebGL, which is the 3D graphics library, and believe it or not, that's not actually part of HTML5. That's not part of the core standard. So although everybody throws it up out there as being a part of it, it is not technically part of it. It also isn't supported on all devices. So although HTML5 has great support on iOS, WebGL is not supported there. Apple wants you to use native code for doing 3D development. CSS3, web fonts, transformations, animations with CSS. One of the big features is WebSockets and for doing finally socket programming, so you can have bi-directional communication from the web browser back to the server, and the server can asynchronously send events back to the client without having to do long polling or polling of the server. It finally does, HTML5 adds support for data storage, so you have access to the file system, local storage, basically a built-in SQL database that you can use, all a part of it. And with HTML5, it's not page-centric like JSF or JSP or servlet. So HTML5 is not just a set of new tags, it's also a different way of developing web applications. There's this concept of a single-page application where your application resides in a single page. It's not something that you're navigating from page to page. So you can actually, if you go to the Chrome store, you can actually download applications that you install in the web browser that are a mixture of JavaScript and HTML code, and that's the actual application, and it actually stores data out. It may, after you install it, it may not actually have any connection back to another server. It can actually be a freestanding application or a freestanding game. So that's one of the differentiating features with HTML5 is this whole concept of single-page applications where you're not navigating between pages like you would if you're writing a JSP or a struts application. So the application, as I mentioned, is coded in JavaScript. You have, with WebSockets, you've got true asynchronous communication with a server, and you may sell the application via an app store like the Google Chrome store. Many mobile apps are actually hybrid applications, so if you download like the local news, like many local news station TV stations have an app that you can install on your phone. In many cases, those apps are just a native shell with an HTML5 content pane in them. And so that gets you the nice little icon that you can click on the launch screen, and then it launches into an application that's just an HTML5 application. And so those are using things like PhoneGap or Apache Cordova to wrap up a HTML5 application and make it look like it's a native application. However, usually you can spot those. Native application development still dominates the mobile. Mobile phones are, while powerful, are still not as powerful as a 2 gigahertz i3. Devices are also RAM limited, and that kind of gets into JavaScript where it does provide garbage collection. So Android does support, if you're developing for iOS, you're writing a native Objective-C code. For Android, you're going to be working in C or C++ if you're not using their Java-based stuff. So you can actually write C or C++ code using the NDK. Now, in terms of HTML5, there are performance considerations. In fact, Facebook, every time somebody tells me that HTML5 is the way of the future, Facebook pulled their HTML5 application and rewrote it as a native application. And so HTML5 does have overhead associated with it. So it's not, if the application is generating tons of garbage and the garbage collector is running a lot, that's going to kill the battery of the phone actually. And so I'm going to hop into a technical comparison now between the two. So I'm going to look at the feature support, the rendering APIs, compare the multimedia support, look at the controls, animation, and also a comparison looking at the 3D support in both WebGL and Javafx 3D. And Javafx 3D comes out with the Java 8 release in March. So the first thing I like to say every time I'm making a comparison between Javafx and HTML5 is that HTML5 is amorphous. It has a basic set of technologies, SVG, Canvas, WebGL, WebSockets, WebWorker, etc., except it has additional functionalities provided by open source libraries. And generally there's an open source library out there that can do just about anything, and the JavaScript libraries are coming out practically every week. There's some new JavaScript library that comes out that does something. So if I say HTML5 does not do X, somebody will say, well, there was just a JavaScript library that was released last week or released yesterday that does that. So it's like you can't actually say, it can't do this because there's a JavaScript library that will, talk to a native code or something like that. There is something out there. So, you have the major ones like jQuery, 3.js, and tween.js, for tween being an animation library. So if you say that, HTML5 doesn't have, built-in support for animation, somebody will point out, 10 different libraries that, that have different ways of supporting animation. So it's almost impossible to argue that HTML5 can't do X. JavaFX, however, on the other hand, is fixed. It's got a robust set of core features that you're guaranteed to get with the platform that are well tested and work across multiple devices. It is easier to use developmentally because you've got an integrated set. You've got the animation is integrated into the core platform. You've got the scene graph. You've got multimedia support. So everything, it's an integrated package when working with it. It does have a smaller ecosystem, although it has 60+ components that come with it by default, which is a lot when compared to Swing. HTML5, there's, everybody's banging out different components. You can download all kinds of different things going through some of the jQuery libraries. So an overview of the HTML5 limitations. So the biggest limitation with HTML5 is the JavaScript language. We're left with many of the limitations to the language that were as a result of its original development timeline, where they were trying to get it in for Netscape back in like 1994, 1995. So, we're still, the language really hasn't changed that much since then. So although it's the latest language, we're still stuck with decisions that were made to meet a Netscape release back in 95. So you have challenges between different browsers. So each browser has different support or behaves differently. So, the old joke about Java was write once, debug everywhere. With HTML5, it's write once and and sometimes write different code for different browsers and debug on 50 different versions of different browsers. You do have, it does lack support for true concurrency. So although it does have the concept of web workers, that is nowhere near as powerful as concurrency support that you have in Java. So if you're used to working with code or writing code that's multi-threaded, web worker is not really going to, more of like kind of a toy when you look at it. It's still, one of my pet peeves is it still doesn't have time zone detection, so you still don't know when somebody visits your website really what time zone they're in, so that you can appropriately localize the display that the user is in, so you can tell them where if they uploaded the file today. That's why when you log into a lot of websites, they'll ask you what time zone you're in, so they can put up a display that renders correctly. It does have long release schedules, so my question is, when's HTML6 coming out, and what are the features in that, and so forth. I mean, we went from, I think, HTML4. I'm not quite sure some of the different versions. We had that little side trip into XHTML, and then XHTML2, which never quite got born and was killed, and then HTML5, and then HTML5. The spec wasn't actually solidified until a couple of years ago, and they were kind of adding and removing features. So it was kind of a spec that was in development. So the web browsers were out before the spec was even approved. So I always like to, when is HTML6 coming out? You still have limited capabilities for interfacing hardware if we're talking to like accelerometers or stuff like that. You don't have that built into it. Tooling challenges. You still are stuck within the web browser, right? Chrome has their own set of developer tools. Safari has their own set of developer tools, etc. And then you also have to, I guess the bigger thing is you have to worry about patent infringement and IP theft. Because if you're writing an HTML5 application, your application is distributed as plain text essentially. So anybody can download it, reverse engineer it, try to figure out how to hack it, for instance. And they can also look at it to see if you implemented an algorithm similar to the way that they did, right? So if it's a compiled application, it's really hard for somebody to try to figure out whether you are infringing upon their intellectual property. Whereas with an HTML5 application, you can look at the source code and say, hey, that's the same algorithm that I own a patent on, right? So it makes it much easier to, surf for, look for patent infringement. So, especially with large vertical applications, it becomes more of a concern. Now, looking at JavaFX limitations, there still is no smartphone strategy, although there has been work at getting JavaFX on the iPhone. And Android, it still is not an official port yet. So, if you're writing a JavaFX, if you're targeting mobile, you're either going to end up doing native Android, native iOS, or an HTML5, or using one of those libraries that tries to bridge it, and then dealing with the limitations of both. So it's still, it's one of the benefits of Java, so hopefully someday we'll get that. It is incomplete. It's still a work in progress. Like I like to say, JavaFX 2.0, I kind of consider it to be the first real release of JavaFX. Its core features are still dependent upon Oracle resourcing, so hopefully Oracle keeps their interest in pushing JavaFX forward and investing in it. It's missing features that you get on some of the native libraries, and also to some degree in HTML5, such as geolocation. So there's not an API to find out to request your longitude and latitude. Device orientation, accelerometers, camera capture, you don't have any of that built in currently. And then finally, another limitation is the perception stemming from Javafx 1.0. So it still has this perception as being a language. So a lot of people that looked at Javafx when it first came out immediately wrote it off, like a lot of people that looked at EJB2, and even though we have EJB3 out, still think of EJB2 and all of its limitations. So it's kind of limited by this initial baggage. So looking at deployment strategies, Javafx, you can actually get Javafx into the Mac App Store and also the Microsoft App Store. HTML5, although I have it listed as neither, I was recently pointed out that I think there is a Firefox plugin that allows you to wrap up an HTML5 application and actually deploy it into those stores. I've not actually tried it myself, so that's a little bit misleading up there. There is now, as I said before, HTML5 is an amorphous target. If I say it can't do something, there's something that came out within the last 2 weeks that did it. So yes, you can get it into both of those app stores. Javafx, you still can't get into the Android or iTunes store because iTunes is native only. And HTML5, you can get into those stores using things like PhoneGap. Breakdown of the operating systems that it's supported on, kind of more of the same from the previous slide. Obviously, we've got Windows, Mac OS 10, and Linux, whereas HTML5 goes across all of them. And then looking at the features, HTML5 feature support breakdown via browsers. These are actually the version numbers up here. I think Firefox is probably up to version 50 now. It's kind of a joke. So as you can see, WebGL right now is still not, at least, was not supported in IE9. So, you know, the support, I like to say, with HTML5, the browser support has finally gotten good within the last year or so, that all the major browsers have added support for it. I've got some more notes down at the bottom. The slide will be up on the web, so you can look at it. Take a look at it later. In terms of rendering, the HTML5 canvas is equivalent to the 2D drawing surface. It is similar to Java 2D, Mac OS 10 Quartz, and I like to pull this one out to poke fun at it, QuickDraw from 1984 on the Mac platform. The first time reading through the API for it, I thought, you know, geez, this is like reading the documentation for the Inside Macs from like '92. The HTML5 canvas is immediate mode, whereas Javafx is retain mode, and I'll kind of get into that a little bit more later and why that's important. HTML5 canvas is similar to the Javafx canvas, so if you're, you know, for functionality, there is an immediate mode canvas in Javafx. HTML5 canvas does not support hit detection, so if you're trying to use that for drawing things, you're going to have to handle the hit detection yourself. In terms of lining up rendering, Javafx the scene graph is roughly equivalent to the HTML5 SVG support, and the Javafx canvas, which is the immediate mode one, is equivalent to the HTML5 canvas element. So that's kind of how they line up technically in terms of the features. And then looking at the 2D support in Javafx versus HTML5, there's really no difference between the two of them. The features, the major features and drawing capabilities basically line up in terms of being able to create rectangles, drawing text, compositing, etc. So in terms of the 2D canvas, Javafx versus HTML5, the similarities are immediate mode rendering, and the API, as you saw on the previous slide, is almost an exact match. Now with Javafx, its immediate mode canvas can participate in the scene graph and also in Javafx 3D. So you can kind of combine the two of them to do some interesting things. And Javafx also supports Svg paths. So when I was trying to draw some things to animate a little sailboat using Javafx, you know, I'll create it using Svg. I won't try to actually draw it using paths, etc. In Javafx, I'll actually generate Svg output that I'll then parse in my Javafx application. HTML5 lacks fill support for arcs and polygons, which Javafx does have. And then looking at feature integration, so this is kind of where the scene graph comes in. So with Javafx, it's all integrated with the scene graph. So your canvas, your video, your audio, your 3D, they're all part of the scene graph, and these features work together. So you can put a video on a 3D, on a sphere and rotate it, etc., and it's all done for you. Now over in HTML5, the features are not integrated. So the canvas element is separate from the video element. There's no concept of like a scene graph that you can apply transformations together and have it perform operations, right? So they're all separate features. So say you want to have, you want to draw text over a video that's playing on the screen. So you want to have some JavaScript code that displays some text over a video that's playing. So what you're going to actually have to do, and there's maybe another way of doing this, since there's always 50 different ways to do something with HTML5 and JavaScript. You'll use absolute positioning, position a canvas, position a video element, and then draw the text. Right, setting the alpha channel. If you put the canvas on top of it, you set it to be transparent, and then draw your text. So that's as opposed to using a scene graph where you have different nodes that handle the rendering for you. So the video and canvas are integrated via the layout, not via like a scene graph. So this makes it much harder if you're trying to develop an application to integrate these different technologies. You're doing the integration yourself. Now, HTML5, if many of you probably remember SVG, which came out in the early 2000s. I was all excited, back in 2002. And then it kind of drifted off, and I kind of thought it was dead. Well, it's actually back. HTML5 has kind of resurrected it. So the first version of SVG was released in 2001. SVG 2 came out and is targeted to come out in 2014, August of this year. So that's when SVG 2 will finally be out. It can be compressed using gzip. The browser support is not robust. IE8 didn't support SVG. It doesn't, or still doesn't support SVG. And some of the modules are not fully supported by all of the web browsers. So SVG is the equivalent of the scene graph in Javafx, where you can have nodes and draw stuff. Multiple. And SVG you can actually leverage in Javafx. I'll kind of touch on that in a couple of slides. So multiple tools can export to SVG. So you have Adobe Illustrator, OmniGraffle Professional, CorelDRAW, and also Inkscape, which is an open source package that you can use to generate graphics. And it can be manipulated via JavaScript. So it's kind of like another presentation format. So if you're trying to do vector-based graphics, which is what you get with JavaFX, you'd use SVG, and then you'd manipulate it with JavaScript. In terms of control, HTML5 and JavaFX both have a rich suite of controls. JavaFX, as I mentioned before, has 60+ controls. HTML5 has a lot more controls out there, especially when you factor in the third-party libraries. Now, in terms of binding, with JavaFX, you have built-in binding support with the binding API, where you can bind the properties and everything together. With HTML5, you don't have that, and when I pointed this out a couple of months ago, I immediately was pointed at this library called knockout.js, which supposedly is trying to do that. So once again, I say, well, HTML5 doesn't do this, and somebody immediately points out a new JavaScript library that does that. HTML5 lacks a windowing API. So if you're trying to develop an application that throws up, has like docking panels that slides out and windows that pop up in front of the things, that's up to you to actually do. Most of the applications that implement it right now, if you've worked with it, are using divs and manipulating Z ordering. A couple of years ago, I tried to write a complicated GUI application using just HTML with divs, and ended up, it felt like I was trying to re-implement the JRE, handling Z ordering and trying to do drag and drop myself and stuff like that. Also, HTML5 lacks, there's no layout managers, Windows menu toolbars, the things that you kind of take for granted. You don't have those things built in by default. There's no framework for extending browser controls. Controls vary, the appearance of controls vary between web browsers. And back to the layout manager a bit. So if you're developing an application, with rich desktop applications, the text changes. So if you're displaying Chinese versus German, there's going to be a big difference. The German word will be 25 characters long. The Chinese word might be 2 characters long. With layout managers, things dynamically size. So if you're doing with HTML5, you're going to have to handle that yourself, because you don't have anything like the layout managers you have with Swing or with JavaFX to handle that. There's also no built-in support for internationalization like you have in the Java platform. And the JavaFX controls, as I mentioned before, are in the scene graph, so you can perform animations and other things with them. Tables. HTML5 still has no native grid component like a JTable Excel equivalent. Now that the table element that you do have in HTML5, you can't actually implement you can't use drag and drop with that, for instance. So you can't drag a row and drop it on another row, even with the support that HTML does have for drag and drop. So most of the table packages that are out there, the open source ones, use a really complicated set of div elements to try to replicate a table, to render a table. And so there's no, as of HTML5, there's still no native grid component that, can do things like table cell joining with drag and drop, for instance. So there's quite a few of them out there with a multitude of them. Yes?
So, you're talking about HTML5 too, or not? I mean,
I'm talking about HTML5 with its, there's no native grid support with it. So the table element really is not a data grid. It doesn't allow you can't implement things like dragging and dropping of rows with it, really. So some of the challenges, are merging cells, copying, pasting, selection. So if you try to, there's several different table packages out there, but you'll actually have to, compare the features of them, because one might support dragging and dropping of just contiguous rows, but not non-contiguous rows, or non-contiguous rows that have merged cells. So it gets very complicated. And they've actually, with Javafx, the version of Javafx coming out, they've actually, in March, Javafx 8, they've actually, they can join table cells and do all kinds of, split cells, etc. So you have all kinds of support for dragging and dropping and all the rest of it, which you don't have in HTML5. Now, in terms of multimedia support, video audio codec support is actually determined by patents with HTML5. With JavaFX, Oracle has licensed many of the formats for JavaFX, so you have a consistent set of formats available. HTML5, believe it or not, supports no audio-video codecs by default. It's up to the web browsers to support the different video-audio codecs. So that's pretty much the reason why if you go to CNN.com, they still use Flash, because otherwise you'd have to have a version of the media for this set of web browsers and then another version of it for this other set of web browsers. So it would dramatically increase your costs of delivering video. JavaFX provides a known set of codecs. It is built upon an open source package, GStreamer. So looking at the video codec support matrix, I'm not going to go over this in detail, but as you can see, Chrome has probably the best support for the HTML5 codecs, and some of the other web browsers like Safari, not so well. And then JavaFX supports those set of codecs on all of the platforms on which it runs. Now, backing up the video, although they're looking at the video codec support, HTML5, comparing the video controller support between JavaFX and HTML5. HTML5 includes a controller for stopping and playing, for the buttons to play video, to stop video, etc., whereas JavaFX does not include any controls by default on it. So you actually have to provide your own play button and wire that up to play the video. Neither technology currently can access individual video frames. So if you're trying to write a multimedia application, that's like Final Cut, you're not going to be able to do that with either JavaFX or HTML5 because neither of them can access individual video frames. Okay, then taking a look at audio codec support. Once again, we've got a variety of different, each one of the web browsers has kind of a different take on it, so it's not uniform throughout. JavaFX finally does add a standard set of codecs so you can reliably play audio. So if you remember back to the swing days, if you tried to play audio back then, it was always Googling for this little code snippet to try to do it and dealing with the limited set of formats that supported. Okay, moving on to animation. HTML5 animation is primitive. Now I know that there's libraries out there and I'll touch on those, but basically animation support with HTML5 is this request next application frame callback. So you get called back on an interval to repaint the screen, and it's your responsibility to do all the rest of it. So unless you're using an external JavaScript library, you're going to have to figure out what your frame rate is going to be, and you're going to have to handle that all of yourself. And you're also going to have to handle the situation where you're running on a device that doesn't support that and it throttles you to, say, battery juice. So you must either use, either build a toolkit or use an animation library like tween.js. So JavaFX has an animation framework built into the platform. All nodes can be animated. including basic UI elements like I keep mentioning. And I think on the next slide I have, nope, I don't have the two subclasses, but there's two different subclasses for animation for doing two different types of animations. But anyway, JavaFX does have built-in animation support. Now, it's still not quite there if you look at the iOS platform in terms of on the flight out here, I was watching some videos on animation on iOS where they now include a physics framework. So all the fancy iOS 7 features that you get where the screen bounces, that's actually now built into a core animation library that they provide for when you build your applications. So looking at JavaFX animation support, it's got a robust built-in animation library. It leverages JavaFX's binding capabilities. And you've got several different subclasses for parallel, sequential, setting up keyframes, timeframes, doing transitions. And if you're not, if you're not using a third-party library with JavaScript, you're going to have to implement all of this yourself. So it's going to be a substantial amount of work. And this is the HTML5 animation support without a JavaScript library. As you can see, depending upon what browsers you're targeting, you may have to have basically kind of like a polyfill to try to handle the different web browsers. Now, shifting gears to 3D support, JavaFX 8 and HTML5 WebGL, which is not technically part of the standard, both support 3D. JavaFX 8 3D support is built upon OpenGL Direct 3D. It provides a built-in scene graph for you, so you don't actually have to implement one yourself. It uses the Decora DSL shader language for doing shading, although I've not actually written any of that myself yet, or tried using it. HTML5 JavaFX WebView does not. Okay, so I'll get to the HTML5 WebView in a second. And JavaFX's 3D, as we'll see in a second, is 3D without the heavy-duty overhead. So how many of you have worked with doing OpenGL programming? Or done OpenGL programming? Okay. So the history of WebGL. WebGL was initially developed by the Kronos group, or is maintained by the Kronos group. It's based upon OpenGL ES2O, the embedded form of OpenGL, which is used on iOS and Android. The API is fairly low level, so if you're going to use WebGL to develop like a 3D game, you're most likely going to have to use one of the existing libraries that are out there. And I don't have the code sample with me tonight, but with WebGL, you're given one graphics primitive, which is a triangle, which means if you want to draw a cylinder, you're going to have to tessellate that yourself. So in order to get, that first, I had the code snippet initially. I spent tons of time trying to go back to college graphics to try to draw my little cylinder that I was trying to draw. I sat down one night thinking, okay, I'm going to do this as part of the demo. I'll demo the code for drawing a cylinder in JavaFX, and I'll do it for WebGL. And after 8 hours, it was like, okay, this is okay, if I'm not trying to use a graphics library, you almost have to use a graphics library. And literally the code went from here to where you're sitting right there. It was 4 or 5 pages worth of code just to get the initial scene set up. So it's extremely basic. So you're programming at an extremely low level. And depending upon what licenses your company allows and everything, you might actually have to develop your own scene graph, right? So if you're building a large graphics application on top of WebGL, you're probably not going to want to depend upon somebody else's scene graph library that could come or go away because which library is going to win hasn't quite shaken out yet. So as I mentioned before, WebGL is not supported in all web browsers. IE support has been lacking. The first version that had it was IE 11. Safari still requires that the user enable WebGL, so you have to go up and go to the developer menu to enable it. And also shaders are written in a C-like language, which is a real joy to try to figure out. And you actually have to write your own shader before you can get something to show up in WebGL. So there's a pretty high... No, that was a pretty, not that I saw, there's a pretty high bar for doing it. So in comparing, 3.js is probably one of the leading libraries right now for WebGL 3D support. Because I couldn't compare it just directly to WebGL. So for Lite, JavaFX has 7, WebGL 3 has 2. Now this is from several months ago, so it could have changed since then. Built-in shapes, JavaFX has 25, WebGL 3.js library has 4. As I mentioned, WebGL with no JavaScript libraries, you only get triangle meshes, and there's also no picking API currently. JavaFX is still a high-level API, so if you're developing a CAD program or something that's not kind of a presentation type thing, you're probably going to, want to dive down into OpenGL directly. So there's things like Jognal already on the Java platform that allow you to do that. So if you really do need to develop your own scene graph and do all the calculations yourself, you can still do that on the Java side. JavaFX 3D does not preclude you from doing that. Now import formats, JavaFX supports, there's several different libraries out there that you can use to import Maya, Collada, Object. HTML5 has a custom JSON format, and at the time that was about all that I could find on it, so that may or may not be correct, but in Googling and trying to research it, because obviously you're not going to create a 3D world programmatically because it'll take you, forever to do a rendering of this room. You're going to use a 3D tool. So though JavaFX has a nice API for doing for building up stuff programmatically, you're probably going to use another tool like Maya or something like that to create your 3D environment. So one of the JavaFX third-party importers is this interactive mesh, which has a very nice library for importing several different formats, including OBJ and STL. So for my demo, this is actually a part rendered in SolidWorks. And actually, you can export stuff from SolidWorks to an STL, and then using that graphics interactive mesh library and the previous thing, you can import it into JavaFX. And that's the NetBeans code right here. So look at my mouse. So it's a little hard to read up on the screen right now. Okay. But there's not, most of this code is just basically setting up the scene. So, I set up my, I use the interactive mesh, the interactive classes to actually do the import. So basically in 2 lines of code, I read in this complicated thing, which I think, if I remember right, when I exported it, it had over 40,000 triangles on it when it rendered. And then it's just basically setting up the scene and the light and everything like that. And one of the nice things with JavaFX, it has a default light source and everything for you, so it's very forgiving. Whereas WebGL, if you don't know what you're doing with WebGL, the first time you fire it up, if you didn't set up your light or your source correctly, your scene will just appear blank or black. And you'll be sitting there going, okay, what did I do wrong? And there's nothing out there that says, okay, there's 4 pages of code, you set up this wrong. So let me run this here. And that open source package actually has a fairly nice demo application. So my demo here doesn't quite look as nice as theirs. Oops, it's on the other screen. So that's what it looks like by default. And I could easily wire this up so I could rotate it. I need to add some shading to it and kind of pretty it up right now. But that's that's basically all 4 lines of code that are really doing that, importing this thing. So you can render something, design something in say SolidWorks, export it to an STL file, and then import it over here. Okay, so going back to slides. So one of the other things that's never really discussed with HTML5 applications is how do you tune them. With Java, you have a lot of support for tuning, for finding out what's going on inside of the Java garbage collector, right? You've got companies like JClarity that have tools that will tell you if objects are being prematurely promoted, how do you have to adjusting your permgen space and all these other myriad of things that you can control, set, and look at to try to find out what's going on with your Java application, right? You can generate heap dumps and then look at to find out what objects are in memory and who's referencing them. With JavaScript, you really don't have support for that, right? So there are tools out there in the web browser that allow you to do profiling and everything else, but you don't have the same tooling support that is consistent. With web browsers, each web browser has its own separate implementation of things. So it's much more challenging to try to to figure out what's going on out there with this stuff. And if you follow some of the JClarity has a pretty interesting discussion list where they go into like performance type things, different people and performance problems that they're trying to troubleshoot. I mean, when you look at that and then look at what's available on the JavaScript side of things, it's not It'd be hard to write a large application and try to troubleshoot its performance problems. In fact, there's some other tutorials online that go over how you write JavaScript for mobile web browsers, for instance. Right? There's certain things that you don't want to do because it's hard for the JavaScript garbage collector to predict what's going to happen so that it can collect stuff correctly. So I think one of the things I heard is that jQuery is not, or one of the things I had read was that jQuery is not typically the best thing for a mobile application, that there's certain problems with it. So this is just some best practices for HTML5 for trying to troubleshoot HTML5 problems, where you have to be careful because your application is running in a web browser with say Flash running at the same time. You can be impacted by other things that are going on the machine. So I've kind of knocked both technologies. So let's look at how to integrate both of them. So I'll look at CSS skinning for components, the web view for rendering HTML5 content, and also SVG rendering. And the web view, I have some interesting code samples in there. So JavaFX uses CSS for skinning. However, when I first pitched this at work, I said we can easily use the CSS file from our website to skin our JavaFX application. And then, I dug down further into it and realized that that was not the case, and that I'd gotten a lot of people excited about something that wasn't exactly true. So JavaFX does use its own CSS attributes, so if you have a graphics designer, you're going to have to relearn the JavaFX ones. JavaFX CSS reader is not fully compliant, at least the last I read, and the properties don't support animation. So I have a button up here, JavaFX, a button that I rendered in JavaFX and one that I rendered in HTML5, and I spent a tremendous amount of time trying to get them to look the same. I can't tell you how much time because it behaves differently from different web browsers. So I actually went to a site and generated the button. So this is the code that was output, and as you can see, there's different things that you use for different web browsers, right? So if you then subsequently try to go in and change the button, you're going to have to figure out how to do it for all the different. You have to either keep that tool handy or know how all the different web browsers work. So that's the code for the HTML5. The JavaFX skinning is a little bit easier to read, but it's not using the same elements as the previous slide, and it still doesn't quite look the same. There were some things that were kind of hard to figure out how to replicate. So looking at the properties, we have our HTML5 property, our HTML5 value, and then the JavaFX property and the JavaFX value that was used. So you can kind of see that they don't exactly line up between the HTML5 and JavaFX. So although, yes, you use CSS for skinning, it's not the same CSS that you're used to working on web applications. But it's still much easier to use than the Swing look and feel architecture. So the web view is one of the big reasons to switch if you're working with an existing Swing application. Is actually a major reason to try out JavaFX because it allows you to integrate HTML5 content into your application, right? So if you're just trying to render like a layout like a report or something like that where it would be extremely time consuming to do it in Java code to create this custom report and you just want to work with markup tags, WebKit is definitely the way to go. The WebView uses WebKit, which is the same rendering engine as Safari and Chrome, although Google has forked WebKit recently. It is a fully functional web browser in that you can render CNN.com, eBay, etc., and it will look like it'll look like it appears over in Chrome or in Safari. So you can develop your own basically web browser if you wanted to, built on top of JavaFX. But you can actually integrate that into your application so people would not even know that the screen that they're looking at is an HTML5 view within your Java application. So you can actually integrate like online help easily into it. The existing Swing control for rendering HTML, I think only can render HTML from like 1997. It's pretty bad. Like the media controls for JavaFX, it doesn't have any built-in navigation controls. So you're going to have to write your own controls for controlling history, for going back and forth. So you get to control all of that. And it's either a benefit or a drawback, depending upon how you look at it. Proxy detection and configuration is challenging. So I work behind a proxied firewall which uses authentication in different ports. It was kind of tricky to get everything working initially, And then I have no idea how you actually get a hold of, like, say, the system settings that the existing system is using, like what on a Windows platform Internet Explorer is using for default. Because I know some applications can automatically detect it and use it. And there's limited control of page loading and monitoring. So in many cases, if you're working behind a proxy firewall, the page will sit there like it's not finished loading for a long time, right? Not quite sure exactly what's going on with it. So it's really hard to figure out what's going on sometimes. In terms of, you do have support for bidirectional communications with the web view. So you can actually have an HTML5 view that you put into your Java desktop application that has JavaScript code that calls Java code, and you can have Java code that calls JavaScript code. So it allows you to integrate the two of them. Of course, you wouldn't want to just allow any old site to begin talking to your Java application, because that could open up some pretty serious security holes. So in this case, here I've actually created a I'm actually talking from Java code to JavaScript code. So I'm getting the JavaScript object from the web engine, and then basically calling this object over there. And then this code right here, I know this is kind of a hidden API, but this is actually, or from what I understand, is a hidden API. I was quite excited when I figured this out. I had to dig through the NetBeans codebase to find this, because I was wondering, how are they debugging, allowing you to find out what's going on inside the web view control and debug it. There's actually a JSON protocol to WebKit that you can talk and send debug messages to. And so that's what I'm actually using right here. So I'm getting a hold of the debugger from the web view, and I'm sending over basically JSON messages to it. And there's actually an API. If you go up to the Google site, you can find or find it via Google, you can find this JSON API that allows you to debug it. So that is how the debuggers are actually implemented inside of Safari, and Chrome, is my understanding, is using this API to it. So you can actually build, although the method is deprecated up there, so I'm not quite exactly sure what's going to happen with future releases of it, you can actually build up your own debugger to debug it. And this right here, I'm actually enabling console output, because when something doesn't go right with your HTML5 page or just HTML page, with WebView, you just get a blank screen, and you've got no console output. You can't go up there and click on console and find out what happens. So this block of code here, if you're trying to use the WebView, is worth a lot to you right now for this, because this will allow you to get the console output and find out what's going on. So every time your JavaScript calls console.log, it'll get printed out. This call right here to system.out will print what the JavaScript code wrote out. So this is worth quite a bit. And one of my things is to figure out that API a little bit more and try to build up something on top of it. So the WebView does enable hybrid applications and allows you to integrate web applications into the desktop applications. So you could actually, if you have an existing desktop application, you could integrate in an existing web application into it and make it seamless. And if it's like, say, an internal application within inside your company, you can have your Java application calling stuff in that application, or you could have that web application make calls into your Java application. So for instance, you could have, like, say, an online help system that when the user clicks on something, show this window, it actually has JavaScript code that tells your Java application to do something. So there's quite a bit of power there in terms of being able to do. Yes?
I'd just like to point out additional benefit. That way you're just writing to one. Additional benefit to what you just said is that you're just writing to, the web view, rather than trying to accommodate all your browsers with
correct.
So it's a stable platform for which to run your HTML5, very predictable.
Yep. So yeah, you could do online help and not have to try to launch, get the default browser on a Windows platform and launch it, or on the Mac platform or on the Linux platform. It allows you to use the same online help throughout all of them, and allows you to integrate it where that online help can actually affect changes in your application. So it's not just a static page that tells you what to do. Some of the limitations, I actually tried this out because I wondered whether the HTML5 geolocation feature worked with it. And sadly, no, it does not. I could not use the geolocation tags and get the location using JavaScript. I thought, man, because since we lack that API in Java, I thought maybe I could use the WebKit thing to get at it. And then unless you're using the API, that hack with the debugger that I showed you previously, you can't set the user agent. So for things like RoboHelp, that has explicit code in there looking at the different web browsers, and then when it sees, JavaFX WebKit stuff, it says, I have no idea what this is. It won't render it. So that's one thing that hopefully will be addressed at some point in the future, is to be able to set the user agent so you can fool other tools. Now moving on to SVG support, as I mentioned, you can actually leverage SVG, which has come back with the advent of HTML5, to do rendering in JavaFX. So you can export complicated graphics from a tool like Adobe Illustrator or OmniGraphical Professional, and then render them in your JavaFX application. Because nobody's going to sit there and write tons of code to create paths and arcs and everything like that to draw a sailboat. You want to go into a tool and fiddle around with it and design it, right? So this is actually taking, dicing up an existing SVG, because it doesn't read the SVG format. Although it can render it in the WebView component, it can render SVG. If you're trying to get it into the scene graph, this allows you to import. By dicing it up, you can actually get this code through, render the SVG as paths in the scene graph. Right. So by dicing it up, you can see how it converted the SVG into, a string that would render within the JavaFX scene graph. And there's a couple of, there's at least one importer out there that tries to do this somewhat. So in conclusion, HTML5, external libraries are necessary to make HTML5 viable. So its base set of features is kind of, the WebGL stuff requires you to, do tessellate triangles in order to draw a simple thing like a cylinder. Binding of controls is not there by default, but there's all these open source JavaScript libraries that allow you to get there. So as long as your application, as long as you don't mind either integrating tons of open source libraries in there and then supporting them throughout the year. So depending upon if your application is one that, will be around for 4 or 5 years, but if it has like a longer life cycle, like 10 years, that's a little bit, you're integrating a lot of extra packages in there. Its weakness is still the core language and feature integration between the different features. JavaFX, in my opinion, is well designed and architected with excellent feature integration. It's not complete. There's still gaps in core features, but we're not. We're only a couple of years into it. And JavaFX 2.0 was really the first version. And it's the next logical step for desktop embedded devices. It is definitely the next logical step to replace Swing. Swing is really old. You can't develop the type of applications that you see on an iPad using Swing. I mean, the amount of code that you'd have to write to do that is practically impossible. And users nowadays, there's still a lot of reasons for writing desktop applications, and users expect those desktop applications to behave like what they see on their iPad or their iPhone. They want to see transitions. They want to be able to do things like that. Windows 8 has added support for touch screens. You've got the multi-touch support on the trackpads on the Macs. That's what users expect nowadays. So Swing definitely doesn't get you there. So that's a major reason for JavaFX. So major concerns with HTML5. One is protecting IP. And I can't stress this one enough, that if you're dealing with something that has potentially a lot of, that's doing some complicated math or something like that, you do have to worry about protecting your IP, because anybody can go out there and download your JavaScript library and, hack it. It seems a lot of websites, you can go out there, if you're designing something from a website, go to somebody else's website and look at the source. Oh, that's how they did it, right? I know there's a lot of web development people that do that. You have to be concerned about the longevity and stability of the external libraries. That market still hasn't quite shaken those out, and where they decide to go, you may not decide to go. So if you built up a large, 3D video game using WebGL and using one of the open source libraries, and then they decide to change it, which breaks your game, what do you do? Browser support and tracking browser releases. It's test on 3 different browsers and 50 different versions that people are currently using. JavaFX concern, it's still missing mobile support, which is the main hole I see. There's always concern about Oracle's commitment to JavaFX. And the technology is not fully developed yet. It's still evolving. The tools are still getting there. We're really on the second release of JavaFX, coming out with JavaFX 8. Some slides, some favorite slides for information. One is if you're looking for more information on HTML5 and HTML5 code, there's this HTML5 rocks.com, which is probably one of the best sources for information on HTML5. And realize that most of the stuff that you do up there, you can actually do inside of the WebView in JavaFX. So it's kind of fun if you try playing around with using that. So we've got some different JavaFX tutorials, the FX Experience website, and then many different articles. And so that's it. Thank you very much.